Mr. Harmless here, and we're going to talk about the Pythagorean Theorem and its converse. So, to talk about this, we're going to talk about right triangles. So, I'm going to put a little box right here in the corner. This is representing a right triangle, and I'm going to use three letters to represent the three sides: A, B, and C. This is usually the common three letters we use to represent the three sides of a right triangle. Now, these two sides that are right next to the right angle are both called legs. This is a leg right here, and we have another leg right there. The side that is opposite the right angle is called the hypotenuse. Okay, so we have the two legs and we have the hypotenuse of a right triangle. Now, with a right triangle, there's a certain, and this is where the Pythagorean theorem comes in. There's a certain relationship between the lengths of these legs and the hypotenuse. If you take the lengths of the legs and you square them and add them together, the sum of these legs squared is always going to be equal to, in a right triangle, the hypotenuse squared. Okay, and so you've probably seen this before. A squared plus b squared equals c squared. Now, this is useful for a couple of reasons, especially starting off with this level of geometry. One of the reasons why this is useful is for finding missing sides. So let's go to an example triangle here, and let's say that this side is 6 and this side is 15. And say it says solve for x, so find this x. So because you can use the Pythagorean theorem with this, because it is a right triangle, first you want to identify the two legs. So notice the right angles here, so the legs are the 6 and the 15. It really doesn't matter which one is A or B, that's not really important. It's just the two legs. The important one is knowing which one is the hypotenuse. Now, one of the things that I do if a student has trouble finding the hypotenuse is I always think about this right angle as the arrow pointing at the hypotenuse. Okay. So you don't have to do that if you don't have any problem finding the hypotenuse. That's great. But if you do, that's one of the things that you can do. So now we got the two legs, the hypotenuse. And so we're going to use the Pythagorean theorem. A squared plus b squared equals c squared. Okay. So the c is the hypotenuse. So we're going to put the x for the c. The a squared and the b squared, right? The a squared, let's put the 6. 6 squared plus 15 squared. Okay, so we've got the a and the b and the c all in the right places. So now we can do the a squared, 36, plus the b squared. And so 15 squared, I believe, is 225, but I'm guessing. Let me grab my calculator here. Okay, I know you can't see the calculator on the screen, but I'm going to plug that in, 15 squared. Oh, yeah, it was 225 equals x squared. And then we can need to add these two together. So we're going to get 225 plus 36. Once again, just to make sure, I'm going to use my calculator. 225 plus 36 is 261. And then the answer to this side right here, right, to solve for this, we're going to take the square root of both sides. We get x equals the square root of 261. Now, it depends on which teacher you have. Most teachers would require a simplification of the square root. I can talk about that in another video, but I'm going to go ahead and simplify this square root. This is actually 9 times 29 is 261. So 9 times 29, so the square root of 9 is 3. Square root of 29. Sometimes they'll just have you solve it by the decimal, which means you're going to work this out. And so the square root of 261 in your calculator would be the other option. Okay, so there's one example. Let's do another example. This time, instead of having the x be the hypotenuse, let's put 11. And I'm going to put 9 right here. And let's put the x as one of the legs. Okay, so I know the hypotenuse is the 11 because it's opposite the right angle. And so I'm going to just plug it straight in here. The x squared plus 9 squared. Okay, x squared plus 9 squared equals 11 squared. Notice that in this case, the x doesn't always go over there. The x goes where it is in the problem. So since it's a leg, it needs to go here. It could have gone here. I could have done 9 squared plus x squared, would have still been okay. So x squared plus 9 squared, which is 81. 11 squared is 121. We're going to subtract 81 from both sides. Okay, so if we subtract 81 from both sides, I believe that is 40. And so we get x squared equals 40. Take the square root of both sides. We get x is the square root of 40. And if we want to simplify that, I know that's 4 times 10 is 40, so we can do 2 square roots of 10. Once again, if you need to see how to simplify a square root, I can show that in another video. All right, so now we've got these two. Let's go ahead and do one more idea here, and this is the converse of the Pythagorean theorem. Now, the converse of the Pythagorean theorem is important because we already know this, that if it's a right triangle, the A, the B, and the C, we know that it's equal. Now, in this triangle, since this is not a right triangle, notice I don't have the right angle anymore. Let's say that let's say the A and the B are still the same length as in this triangle, but let's say the C is smaller, okay? So I know that it would end up looking like this. The A squared plus B squared is larger than the C squared. Anytime this happens, if the A squared plus B squared is larger than the C squared, then this is going to be an acute triangle. So now you can go with, if you have all three numbers and you're just trying to determine what type of triangle it is, this is a nice way to tell, is it a right triangle? Yes or no? But then is it acute? Or in this case, let's say the A and the B are the same, but the C is larger than it was in the right triangle. A squared plus B squared smaller than the C squared. That would be an obtuse triangle. So you can determine what type of triangle you're dealing with when you're dealing with the converse of the Pythagorean theorem. So let me do one example of that, and then we'll go from there. Let's say that, let's go with the sides. Let's say I gave you these three numbers, 7, 14, and 16. Okay, so let's go to a new slide here. Let's say I gave you these three numbers, 7, 14, and 16. So let's say I gave you these three sides, and I said, let's say you have this triangle. Don't know what it looks like, but it could be a right triangle, could be an acute triangle, or an obtuse. And let's say it says to determine what type of triangle that is. Well, if it was a right triangle, this would have to be the hypotenuse. And so I'm always going to set it up based on that. So I'm going to say 7 squared plus 14 squared. And I'm going to put a little question mark here. I don't know if it's equal, greater than, or less than. And then we'll put the 16 squared over here. So 16 squared is 256. Over here, the 7 squared and the 14 squared. 7 squared is 49, the 14 squared, and then if we add those two together, after I square them and add them together, I'm going to get 245. So notice this is smaller than, it's less than. So the two sides are less than this third side, so this would have to be an obtuse triangle. So there's the basics of the Pythagorean theorem, how to use to find a missing side, and how to determine what type of triangle you have. I have other examples for you to work on, and after you try those, feel free to ask me any questions.